where a single cosmic event permanently changed the face of the Earth. In less than a second, rock melted, minerals shattered, quartz fractured at the microscopic level, and even basalt had its atomic structure violently rewritten under extreme heat and pressure. Earth quite literally took a cosmic slap. And the craziest part? This is not in America, not in Iceland, and not in Antarctica. It is in Maharashtra's Buldana district. Here lies Lonar, one of the world's rare hypervelocity impact craters formed in basalt, making it an extraordinary natural laboratory for geologists. Now imagine this. Our ancient ancestors, perhaps even Neanderthals, are living through an ordinary day when suddenly a bright fireball appears in the sky. For a moment, it looks beautiful like a shooting star, but it is anything but. What they're actually witnessing is a meteoritic body hurtling toward Earth at several kilometers per second. At such insane speeds, collision stops being a normal collision and becomes pure explosive physics, an enormous burst of kinetic energy instantly converting into extreme heat, crushing pressure, and a catastrophic shockwave. Pressures reach the gigapascal range, equivalent to millions of times normal atmospheric pressure, so intense that solid rock briefly behaves like liquid. The resulting blast, far more powerful than a modern atomic explosion, violently excavated the Earth's surface and created the Lonar impact crater, a scar in basalt that still preserves the signature of one of nature's most extreme geological events. First comes the compression stage. Rock is violently crushed under an immense shockwave. Then comes the excavation stage. Shattered material is blasted outward at enormous speed, forming what geologists call ejecta. Finally comes the modification stage. The crater begins to settle, collapse, and reshape into its final form. But here's the twist. This asteroid did not strike some random sedimentary rock. It hit directly into the Deccan Trap basalt, ancient volcanic rock formed nearly 66 million years ago during one of the largest volcanic events in Earth's history. Massive flood basalts, layer upon layer of lava, building a thick volcanic rock pile over immense stretches of land. And then, thousands to millions of years later, space rock enters the chat. That is exactly what makes Lonar extraordinary. In impact events, minerals can record shock in ways ordinary geology rarely can. Quartz, for example, can develop shock-produced polymorphs and microscopic structures known as planar deformation features, or PDFs. Tiny parallel lamellae etched into crystal grains, clear signatures of extreme shock. Normal tectonic processes do not easily create features like these. This is impact metamorphism, geology in absolute turbo mode. Unlike conventional metamorphism, which slowly transforms rock over thousands to millions of years through heat, pressure, and fluids, impact metamorphism happens in milliseconds to seconds. Extreme heat, extreme pressure, atomic bonds distort, crystal lattices collapse, glass can form instantly, minerals develop shock scars. Entire rock fabrics can be violently restructured in a geological heartbeat. And this is where forensic geology begins. How do we know Lonar is truly an impact crater? Because rocks may look silent, but they remember trauma. Their minerals preserve the evidence. Some studies from Lonar have reported shock features in quartz grains, suggesting intense impact processes and mixing of target materials. In other words, the rock is practically saying, "I got hit hard." During shock events, minerals do not simply crack. They can melt, structurally transform, and even turn into glassy phases under extreme pressure and heat. In studies related to Lonar, researchers have discussed Maskelynite-like glassy material and other impact-generated glass phases. Simple way of saying it, the crystal structure gets completely wrecked. And here is what makes that fascinating. Similar shock products have also been found in meteorites from the Moon and Mars. So yes, a crater in Maharashtra is actively helping scientists understand other planets. Which means Lonar is not just a lake. is a planetary laboratory. But the story does not end with the impact. Because after that cosmic collision, nature built something even stranger inside the crater. A lake with unusual chemistry, unusual microbial life, and reported magnetic anomalies. Basically, the crater formed, and nature said, "Now watch this." Normally, lakes are simple: freshwater, ordinary chemistry, fish, frogs, some algae, standard package. Lonar chose a different path. Its waters have historically shown notable salinity and alkalinity, meaning this is chemically no ordinary lake. The pH can rise well above typical freshwater conditions. Dissolved salts can become significant depending on hydrology and seasonal change, and that combination dramatically shapes the ecosystem. Microorganisms found here can tolerate harsh chemical extremes, alkaline conditions, saline influence, and constantly fluctuating chemistry. These are the kinds of ecological adaptations scientists often discuss in the context of extremophile life. And that matters for one huge reason. If life can survive in difficult chemical environments on Earth, then scientists naturally ask, could something similar once have existed on Mars? In other words, if you understand Lonar, you are not just understanding Maharashtra, you are understanding planetary collisions themselves. If you want more hardcore Earth science breakdowns, subscribe to Stone Theory Productions and see you all in next Pixie video. Bye-bye.